But the title is Joint Point and Line Segment Matching on Wide Baseline Stereo Images. Unlike many other image matching methods which explore the feature point on images, our method instead explore the line segment. This is because line segment can be as useful as feature point in many applications, such as 3D reconstruction, camera calibration, etc. Also, line segment is abundant in many man-made scenes, such as buildings and indoor scenes. Another benefit for line segment is they can depict the outline of the scene very well, as we can see in figures on the right. Our method, the proposed method can obtain point and line segment matches jointly, and thus benefit for applications which need to explore both point and line segment on images. The basic idea of our method is that we first intersect the adjacent line segment and form V junctions, and to match V junctions from two images. If we get two corresponding V junctions from two images, the two pairs of line segments forming the two V junctions can be matched accordingly. For example, if we intersect refer to the figure on the right, we intersect L1 and L2, generating the V junction J on one image. On the other image, we intersect L1 prime and L2 prime, generating intersection V junction J prime. If we can match J and J prime successfully, we can obtain one point match J and J prime and two line segment matches L1 prime and L2 prime. With this idea, two problems need to be solved. The first is how to match V junctions. The second is how to match individual line segments far away from others and are not used to form V junctions. For example, L3 and L3 prime on the figure below. To solve the first problem, we propose to extract each V junction, a scarce and affine invariant local region. We find an invariant point for each line segment forming a V junction. The invariant point on a line segment is one whose intensity changes most abruptly relative to its neighbors along the line segment. The paragram formed by the V junction and the two variant points on the two line segments is the extracted local region. After that, we expand the paragram to get a larger one to include the signal variance on the edges. And finally, we rectify the expanded parallelogram into a square and describe it with shift. Once we described all V junctions from two images, we can match V junctions. Besides evaluate their description vector distance, another factor that can be used, that is the crossing angle of the two line segments forming V junction remains stable with image transformations. And after obtain some putative line segment matches, we refine it by two constraints. The first is the epipolar line constraint, and the other is the relative position of adjacent V junction remains relatively stable. And another problem needed to be solved is individual line segment matching. We propose to estimate the local planar homography from estimate fundamental matrix and a pair of corresponding V junctions. The figure below shows how this works. And finally is the result. First is the local region detector. The figure below shows that the table below shows that our detector is indeed better than some other famous one. And besides, it can be very powerful and effective for matching V junctions when incorporating with other strategies planned above. And then in the point matching method, we compare with SIFT, and the result shows that our method can get more matches than SIFT. And the final page is that we compared with line segment matching method, and it shows that our method can get more total matches and higher accuracy and less time. Thank you. If you have questions, go to my post.